thanks all for coming. My name is Marcelo. I'm going to be talking today about the gRPC code generation pipelines, which is a system that we have built in ANZ recently. And well, let's get started. To begin with, I'd like to introduce you guys APIs, right? This is our APIs. And what is it? Well, it's the home of all of ANZX APIs. Yeah, it's 100% built in protobuf and gRPC. It is absolutely free of any JSON, which it being protobuf makes it backwards and forwards compatible. It being protobuf, it's also platform agnostic, which means that we don't pick favorites, because even non-iOS developers can be happy, right? Gotta think about them sometimes. Also, I'm not gonna be digging too much into the whole concept of protobuf, but more on the code generation part. But if you do feel yourself compelled, go back and watch Box Unbreakable API Contracts with gRPC, which was presented a couple months ago here in CocoaHeads. One key thing about our APIs repository is that it's paired with tech-specific code generators. And what is that specifically? Which means that our APIs repository does not deal with any tech-specific components, but we delegate that to platform-specific, such as APIs Swift, which is a very original name. We have APIs Kotlin is another example. We have APIs Go, and we have more, but well, just for briefness sake, I'll just keep to these. And the way that this whole thing works is that every time a new API has changed, which actually is done through a PR being merged in the APIs repository, we ship off a tag, and that tag enables code compilation for these specific platforms, which in their own instances, they get shipped as artifacts to their specific technologies or platforms, right? So API Swift ships to Apple platform, APIs Kotlin to Android, and maybe some Java backends that we might have, and APIs Go is mostly focused on backend integration. API Swift specifically is fully automated, and it generates everything in Swift code from our protobuf and gRPC APIs repository, right? It's fully in Swift, specifically for people that use Swift, us. It's Swifty. It's fast. The whole purpose of it is so that our Swift developers, our iOS developers, don't need to worry so much about what happens from the point where protobuf is specified to the point where the code generation is happened and they have to absorb to the libraries or to the APIs from the application. And the way we deal with things is that we generate XCFrameworks out of our APIs. So on the grand scheme of things, what we do is we receive tags from our APIs, which signify that there was a change in one or two or more libraries in APIs. API Swift goes and builds those and delivers artifacts to our artifact registry. And that in turn gets observed in the ANZ Plus application through binary targets. So this presentation is going to be a study of what happens in between receiving a tag and generating an artifact. Okay, we're going to go step by step here. Well, first thing that we have to do is actually we have to generate something that we have to generate the protoc plugin that actually generates the Swift files, right? The way protobuf works is that it has a compiler shipped with it. It's called protoc, protoc, and it works with plugins. And there is a Swift protobuf plugin, and there is a gRPC Swift plugin. And those plugins, they are open source projects as well, and they get versions. So we have to make sure that we're building with a version that's compatible with the libraries that we have in the app. Okay, so the way we use these plugins is on the command line. We just, when we call protoc, we just apply the path to the plugins themselves, right? And the version that we want to use of these plugins is the versions that API Swift was built with, because the code that we generate is also the code that we're going to be observing and processing. So the versions that we want to use are the versions that are specified in our package.swift file. So how do we do that? How do we generate plugins that we can use by ourselves as well? And the answer is quite cool. The answer is through build plugins. So every time there is a build, we have a build plugin that depends on the code generator, on the protoc plugins, builds them on the right version according to the version that was added as a dependency, and copies that into somewhere that can be observed by API Swift specifically. In this case, it makes it generated available through a bundle within the app. So that in that way, now we have the protoc plugins that we need to actually build the Swift and gRPC code. Next thing that we have to do is, when we receive a tag from the API's repository, we have to figure out what to build, obviously. And it's not as simple as just pointing out to the changes and just building it. We have to know what we're building needs, right? So we actually need to build a dependency tree. Now, to navigate you through this, I'm going to give you some examples. They are not actual protoc files that we have in our repository, but they give a representation of what we have. So, for example, suppose we have a repository that has a payments proto file, and this payments proto file is able to do a pay request. Is my mouse showing? No, my mouse doesn't show. Anyway, so in this specific proto file, we have one RPC that it sends a message called pay, and then in the pay request, it has a payment request and it has a payment response. But you see that the payment message here is not specified in this file, so it's specified somewhere else. In this case, it's specified inside the same package, which is the payment package that we can see here in the import. And we can see the import actually to the type to the proto file where the payment is specified, which is this one. So we know that the payment has a dependency on the type proto that specified the payment message. Now the payments message, you're going to see that has an amount, which is an integer 64, which is not a good type to store an amount, as don't do this at home. And we also have an account that we use to specify which account we are going to make the transfer to. Now this account also is not specified here inside this message, inside this protobuf file. It's specified somewhere else, which is in the account/type.proto that we see imported there, which is this file here. So in this example that I'm walking you through, suppose that the tag got generated when the services.proto file got modified, in which case we're going to find out, compare the current tag to the previous tag, find out that services.proto was modified, and we're going to have to find a dependency tree of the dependency, so we have all the information that we need to compile. Luckily for us, if you want to explore or navigate the dependency tree, protobuf makes something available that's called the descriptor set file. Yeah, and we can use the protoc for exposing that. And that actually is the same file that protoc uses to communicate with the plugin generation plugins, with the specific code generation plugins. And with that, we can go through all our protobufs and we can generate a descriptor set that let us know the exact contents of our proto structures. So in this case here, we have, say, the descriptor protobuf. The descriptor set file is actually a binary file that was serialized from a protobuf file. And if we deserialize it in JSON, and here we are using JSON again, if we deserialize it, we're going to see that it has all the metadata that we observed just previous slides on the protobuf files. Now, how do we observe to this data so we can actually navigate and build a dependency tree? Well, it happens that since the descriptor file is actually the mechanism that protoc has to communicate with the code generation tools, protoc also, any code generation tool, we also be able to absorb to this descriptor file and be able to understand it. And it happens that Swift is no different. Swift has a library. Swift protobuf has a library that's called Swift protobuf plugin library that we can use to open the definition file, and we can, from it, we can find all dependencies that each of the files have. And that's what we do. We open the descriptor file, we open the Swift protobuf library plugin, then we navigate through all the dependencies, and then we create a dependency tree, which is simply a graph of objects. And we call it the protographer. Thank you. From there, before we actually generate any Swift code, there's also one extra step that we have to take. That's called building the module map. And a module map is a link between the protobufs that we want to compile and the actual generated Swift code. We have to, it's a way that is a specific to Swift way that we can use to tell it that, for example, in our case here, a payment, when it comes from a payment package, is actually going to be called as a module payment in Swift. And these are the proto files that belong to that specific module. And the same for account. And with that, with the Swift protobuf plugins built, with the navigation tree, the dependency tree built, and with the Swift modules mapped, we have everything to do to generate our Swift code from the protobufs. Yeah? So let's go step by step. So for our protoc command, we're going to start by specifying that we want to use a Swift, the Swift outs, which means that we want to specify that we want to build Swift code in this command line. We want to specify which plugins that we want to use, which are the plugins that were just built. We want to specify the mappings that we just defined as well. And we want to specify the files that we want to build. And ta-da! We have Swift code generated for us. Thank you. So when we do the generation of the code, we end up with an equivalent like this. We have, in our instances here, in our situation, we have a services proto, a type proto, and a type proto from accounts that they have converted to equivalent Swift codes generated by the protoc plugin, the Swift protobuf plugin, and by the Swift gRPC Swift plugin. They get their own files. And what we want to do next is that we want to wrap this up in a proper, we want to wrap this up in a proper Swift project that has a proper Swift structure. So we're going to do that in two steps. Firstly, we're going to repackage move the generated files around so that they have the proper module names, because Swift protobuf doesn't do that for us. And then we're going to generate, manually, we're going to generate a package.swift file. And with that, this is what we end up with. We end up with a fully self-contained project that has the generated code from Swift protobuf. And we end up with a package.swift, and you actually build that. And you can build that and generate a package library as if you would be generating any other package.swift file. Now, up to this point, it was beautiful. It was clean, it's package.swift, but starts getting dirty from here. Because now, when we start generating XCFrameworks, first thing that we're going to be doing is we're going to be generating an Xcode project. And yeah, we cannot live in Swift package manager land forever. We have to work with Xcode as well to generate archives, XC archives, which is going to be our next step. And with that, we are going to be depending on the Swift package manager, which in version 5.7, which is the version that we depend so far, it has a component that allows you to generate programmatically an Xcode project. And if you do generate an Xcode project, it will be generated like something like this, which is an Xcode project that contains, you can see that all the targets that we were building in the previous step, it contains the payment and the account, plus all the Swift protobuf and gRPC Swift dependencies, which is a significant tree, actually. With that, we make a choice to what XCFrameworks we're going to create on next step. We can generate XCFrameworks from any of those schemas that gets generated automatically here. And we choose, when we're building for a specific library, we choose to build only for the library in case. In which case here, it's going to be for the payments library. That's the one that had a change in the beginning. But when we build, we actually go one extra step, and that we don't actually archive the project only for, we don't archive only for an iOS, but we also archive it for an iOS simulator, for the Mac, and for a Mac Catalyst as well. And that is so we are future ready, and whatever tools we have in the future that uses any variants of the APIs that we use, we're ready for them. So we archive them all. And for sake of efficiency, we do them in parallel. Everything that I've talked through up to this point is run on CI. The developers have no touch on it while the libraries are generated. So on CI, what we do, So on CI, what we do is that we run 4 different jobs over a matrix. Each of them, each of them building its own XC archive, because XC archive, if you ever archived any project in Xcode, you will know that is a very expensive operation. And when we call each of these platforms in CI, we call using Xcode build, of course. With the archive command, we specify which project we're archiving, we specify the scheme that we're archiving, which you will remember comes from one of the targets that we had before. You specify the destination, that's a directive from Xcode build that specifies what platform / architecture / vendor that's going to be building on. The Trinity, the configuration, and last, if we're going to be generating XCFrameworks, we need to specify the build library for distribution and the skip install options. Cool. So we run that for all of our instances building for different platforms in parallel, and then after they're all built, we create our XCFramework. We get the XC archives created, and we put them together in a single XCFramework. And that is another Xcode build command, which is a newer command. So what we do is we go through each of the archives that we created. We point out which framework inside those archives that we want to include in the XCFramework. And there will be one for iOS, one for the simulator, one for macOS, and one for Catalyst. And we specify the output file. Okay? The last step of this process is actually preparing for us to actually upload an artifact to be able to be observable from the end of that being the ANZ plus app. And to do that, first thing that we have to do is gotta get this XCFramework that was created, and we gotta name it with a version name that makes sense. So what we do is we call it the framework name. We call it, we put a tag number because the tag that came from APIs actually represents the version that it was built from. And then we zip it. And that is our archive. In our case here, in the example we're walking through, it was payments dash, for example, 330.zip. Yep. So this is what we covered. We covered what happened from a definition of a change in an API in the API's repository until the point where the artifact is generated and put into our artifacts registry, and then observed from our APIs, from our end, which is the NZ+ app. Okay. Now, just to give a perspective on how this runs and the magnitude of what happens is that, firstly, we have about 140 APIs, and that is sometimes the same API, but in different versions or in different parts of their life cycle. Some are in alpha, some are in beta, some are actually ready for production. If you sum them all, we got about 140. A lot of them are in actually active development. At a specific time, we have 40 APIs being consumed by the NZ+. And since the system was conceived, we have generated 450 artifacts in a cadence of around 5 to 10 per day. And with the latest interaction of the build, with all the gains that we were able to achieve, thanks for Pete for a lot of help in that scenario as well, we're able to build each artifact with about 10 minutes. One thing else that we do is before actually PR is merged into the API's repository, we're able to check if it actually builds. So everybody that's doing a PR in the API's repository gets checked by API Swift. And if API Swift cannot build, which goes all the way until the phase where we actually build the package.swift, then if that phase is not successful, then we reject the PR and the author has to fix it. We got 30 of those per day, more or less, and each of those take 2 minutes. One else thing that is important to get a number across is that we have about 70 iOS developers consuming our APIs, and the estimate of that is that they have an infinite level of happiness. Seriously, everything that we have done from the concept of the API until the artifact arriving and the consumption, that's done automated. And a lot of our developers know exactly what's going on, and they are able to actually generate it themselves if they would like to, but they don't need to. And that just makes everybody's life so easy. And that's what I had for you guys today. Did anybody have any questions?
Not a question, but just a statement to sum up the impact of what this actually does. It means that within 10 minutes of the type-safe APIs being approved and merged in the PR repo, they're available for iOS developers to consume in the app and build type-safe SDKs and API calls against. And that's been a massive journey, like months and months and months of effort for Marcelo. So, yeah, well done.
Thank you.
Question back here somewhere? No?
So once the so how are they consumed? Do you have to put them in the project manually? When you're ready to consume?
Well, they are binary targets, right?
Okay.
Maybe the way you consume binary targets, you specify the URL and you specify a checksum for it.
Okay. Cool.
So, yeah, we kind of put some helper functions in the middle to make it simple to just specify the name and then the version and then the checksum, which people can get from the artifact registry. But it's as simple as that.
Cool. I wanted to start with a thank you for the talk, but I guess came back. Sorry, one more thing. Sorry. So even the packages could have been consumed, right?
Yep.
Is the reason you guys went from using the XCFramework and doing all that?
Yep.
Publishing package could have been one way to do it.
Well, I think it goes down to two things really. One is version management, because we want to wrap up different versions of APIs in different binaries, and the other one is Swift doesn't really have at this point a way of us to keeping like separate projects with different versions, within project.
Yeah.
So if we had a project within a project and 40 of those
Okay.
within the project itself, that would have been a management by itself. So we wanted to simplify that by wrapping it in binary, XCFrameworks,
Okay.
and just calling the right thing at the right time.
Thank you.
Sounds good?
Any other questions? Sorry, how is the archiving here different from Xcode archive?
Xcode archive. Oh, it's actually the same process, but we do it automated instead of going through ID.
All right.
Thank you.
Yeah. Actually, there's one different though. Just to clarify, in order for you to create an XCFramework, you have to specify that it's non-installable and it's buildable for distribution. There are some parameters that I have to specify, but apart from that, it's just an archival. The only thing that you have to keep in mind is that once you specify those, you have to make sure that whatever you are archiving is API stable, which means that it complicates with some libraries really, because for you to guarantee API stability, you have to make sure that future versions of the app will be compatible with future versions of a library will be compatible with your library. So you got to make sure that sometimes with like inlineable operations that can break API stability. So you got to look after that. But apart from that, that's just an archival.
Thank you.
I've got a quick one. What do you see as, like, what's there to do for you now? Like, you've told us where it's at, but where's it going?
It's a good question. We're dealing with artifacts directly, right? It'd be great if we could do better at dependencies and versioning. Dependencies, as in if payment depends on account, we specifically specify that we need the account XCFramework and the payment XCFramework. It would be great if we didn't need to. So next step would be to investigate how better to find dependency and automate that.
Anything else? I think we're good. Thank you, Marcelo.